my screen isn't quite big enough. I mean, I would like it if it was bigger. So, okay, so let's see. We're into taking geometry, turning it into algebraic equations, and solving.
Yeah.
So what do we know is true about on number 32 here? What kind of triangle is that?
It's an equilateral triangle.
Okay, what's another property that equilateral triangles have?
All the sides are the same length along with the angles.
Okay, what are the angles? What's each one of them?
Like what do you mean?
What do they total?
Oh, they total to 180 degrees.
So what's each one of them if there's three equal ones? It's 180 divided by 3.
Yeah. I don't know. 60?
Yeah. Probably should have a calculator in front of you.
Yeah, I'm using my phone, but it's being weird, so.
Oh, okay.
I got it. It's working now.
Okay. So if we know that that angle is 60, then we can say what equation?
60 plus 3.
No. Equals.
No. Equals. Okay.
Equals what?
3x minus 15.
Now let's solve this equation.
Okay, so add 15. Plus.
So read the next line to me, and if you want, tell me what you're doing, but what would the next line be?
So you have to add 15 to both sides, so then you get 75 equals 3x.
Got it. And finally?
And then you divide 3 by both sides, and you get x equals 25.
Okay. And that's all we needed, was to solve for x. And that also means that's 60 degrees, if you check it.
Okay.
Okay, hold on. Okay, with this one, what equation can we write? First of all, there is a theorem that relates the alternate exterior angle, that relates the exterior angle to these two angles. What is it? Remember?
Not quite.
Okay. Well, here's one way. This is equal to the sum of those two.
Yeah.
Okay. And let's examine this angle right here. Let's call that Z.
Okay.
Okay. So 146 is supplemental to Z, correct? Because they're a linear pair? Okay. And the sum of those two angles, 5x minus 18 plus x plus 8, is also supplemental to Z.
Okay.
If that's Z, all three of them have to add up to 180. And any time that you have something that has to add up to 180, it's supplemental.
Yeah.
So 146 is supplemental to Z, and the sum of those two angles are supplemental to Z, which means that 146 is equal to those two angles.
Okay.
And then what's the next line?
So 146 equals 5x minus 18 plus x plus 8.
Okay, what are you going to do as the next step? In other words, that's what we've got written. And you're correct. You can remove both parentheses. I don't really need either set. They're not useful. And I can just erase them like that. So here's what you had. 146 equals that.
Yeah.
Okay?
So then would you combine like terms? So
Yes.
would it be 4x?
Well, you got a 5x there, and you got a plus x there.
So 6x.
6x.
Okay.
And the numbers, you got a minus 18, you got a plus 8.
That would be negative 10.
Okay. Now what?
Okay, and you add 10 to each side.
So we get 156 equals 6x. And finally,
And then you divide. 156 divided by 6 is 26.
okay. Let's look at 34. Okay. Can you excuse me just 1 second? There's a fly. I've got to go get a fly swatter. He's driving me crazy. 1 minute.
Okay.
All right. These flies are pretty clever. Once they see the fly swatter, they go. They disappear.
They do.
Must be a process of evolution. The ones that don't recognize it get killed. So, all right. So what kind of triangle is that?
This is an isosceles triangle.
Correct. And the fact that they drop a vertical from the vertex and it's perpendicular to the bottom means what?
Not quite sure. We haven't gone over stuff like this yet.
Well, hold on 1 minute. Let me think about this problem for a second. Well, what it means is that it bisects the base.
Okay.
Okay? If I were to drop a vertical and it didn't make a 90-degree angle, in other words, let me draw what I'm talking about here. In other words, if you have an isosceles triangle, like that,
Okay.
that side's equal to that side. Also, that angle's equal to that angle. That's very important to know, even though it's not applicable in this problem. But that's the other property of isosceles triangles. And now, if you drop a line from the vertical and it makes perpendicular with the base, then that side is equal to that side. Okay, and I use a double hash mark because it's not the same as the single hash mark. This single hash mark is equal to that single, and this double is equal to that double. So that being the case, what kind of an equation can you write? The two bottom pieces are the same.
Yeah.
Two x minus 4 equals x plus 8.
Okay.
Okay. Not quite sure why they put this in here. That's not really going to help us solve for x. We can solve for x completely with this. Okay, what's the next step here algebraically?
Combine like terms.
Not just combine like terms, but combine like terms and put all the variables or the things with x in it on one side and all the numbers on the other.
Yeah.
In one step, move that to that side and move that to that side. What do you get?
Would you get 3x?
No, in order to move that,
You have to
there's exactly. Now, the way they teach you to do it in school is they want you to do that, and then I would have to do that. Okay? Well, I feel like I want to speed it up a little bit. If I want to move a term to the other side that's being added or subtracted to something, I just do it and change the sign. So
Okay.
when I move a plus x to the other side, it's going to become a minus x.
Yeah.
Okay, what's 2x minus x?
1x, but that would just be x.
And then what's the right side?
4?
Well, I got to add 4.
Oh, you add. Okay. That would be 12.
Uh-huh.
So x.
And that solves for x. Oh, that fly came back. Hold on. It was only smart for a while. Got it to land somewhere. Hopefully I didn't disconnect the phone. Okay. Yeah. What did the problem call for here? It might have. All of these are solve for x, correct?
Yeah.
But
This
no. This is not solve for x. This is the perimeter.
Okay.
Okay, and that's different because I was wondering why they put this in here.
Yeah.
So x equal 12. So what is this side equal to?
Wouldn't you take
Plug in 12 for x. In other words, they're telling us that that side is 3x minus 3.
So you do 3 times 12 minus 3?
Correct. That's 33. What's this other side?
It would be the same.
33. What's this left part of the bottom? It is 2x minus 4.
20?
And what's the right side? You don't even have to plug it in.
20.
And the total?
Is 106?
So that's the perimeter. Okay, let's look at 35. Hold on. Now 35 is another one where they give us the perimeter and they want us to solve for x again.
Okay.
Okay, so the whole game, name of the game is what kind of an equation can we write?
Well, this looks like an equilateral triangle. No.
It looks like one, but they don't tell you that it is, and you can't assume it.
Yeah.
If they don't put a hash mark, or at least tell you that it's equilateral. But what information did they give us? The perimeter is 96 inches.
Yeah, so couldn't you just, maybe not.
Yep. Say it.
Plug in 96 for x?
No. How do you get the perimeter of this triangle?
By adding up all of...
Okay, there's your clue. Add up all 3 sides. Add them up for me. I mean, let's list the equation first. The number one thing is to always write an equation, then solve it.
Okay. So it would be 5x minus 13 plus...
Put parentheses just for clarification. We probably aren't going to need them, but just, so plus what?
Plus 4x minus 3 plus 2x plus 13.
And what's on the other side of the equal sign?
And it equals 96?
Correct. In other words, they've told us that's the perimeter. Those are each of the three sides. Now, in point of fact, I don't need any of these parentheses.
Okay.
If any of these signs was negative instead of positive, I would need it. It would make a difference.
Yeah.
But when everything's positive, I can just erase them. I don't need them. Now what?
So then you combine like terms.
Okay, go ahead.
So that would be 5x plus 4, that's 9 plus 2 is 11. So 11x.
Okay.
11.
And then I found the easiest way to do this is to combine all the numbers that are on the same side and then move it over.
Okay. So then negative 13 minus 3.
Before you do that, look at the third number.
It's a positive 13. Oh, so they would just cancel each other out anyway.
Yeah, and then you don't have to do the hard math.
Then it'd just be 3. Okay.
So now we're here. What's next step?
And then you add 3 to both sides. So 11x equals 99. 11 and 11, and x equals 9.
Correct. We've solved for x. Okay. Let's see. Here, next one. And they want us to solve for angle C, which is just slightly out of the picture. That's over here. So it's this angle right here that they want us to solve for.
Mm-hmm.
And notice that the only C we see in the picture is a side length C.
Okay.
Usually when they're talking angles, they use capital letters.
Okay.
In other words, if we could see that, it would be a capital C.
Yeah, it is a capital C.
Okay. So, what equation can we write? What do we know about the sum of the angles of a triangle?
They equal 180 degrees.
Okay, so what's the equation?
So it would be 2x plus 13.
And I know I'm adding everything, so I'm not even going to put the parentheses. Go ahead.
Okay. Plus 5x plus 15
Okay.
plus 2x minus 10 equals 180.
Okay, gather everything.
So that's 9x plus 13 plus 15. It'd be 18.
Good.
18 equals 180 degrees. Okay. And then you subtract 18 from either side. So, and then 9x equals 162.
Uh-huh.
And then you divide 9, and you get x equals 18.
So what is angle C equal to?
So then you just plug in x. So
2 times 18
minus 10.
9. So that's
It's
36.
26.
Correct. Okay.
Okay.
Exterior angle measurement. In other words, they want, that's the exterior angle. Okay.
Yeah.
Okay. What do we know about it?
It equals 180.
No, it's equal to the sum of the two angles that it is not next to.
Okay. Oh, okay. I remember.
Remember that that is supplemental with that, right?
Yeah.
They're a linear pair. They're always supplemental.
Mm-hmm.
And the sum of these two angles are also supplemental to that angle. Because the sum of the angles of a triangle add to 180, so whatever these add to and that have to add to 180. That makes these two supplemental to that supplemental to that. Therefore, that is equal to the sum of those two.
Okay.
Give me the equation I can write.
So it'll be 8x minus 4 equals 54 plus 4x plus 2.
Okay. Again, I don't need any parentheses. Be a little careful because sometimes you are subtracting. There are going to be problems where you're subtracting, and then when you're subtracting something like that, or this, then parentheses are very important.
Okay.
So let's gather our x's on the left. There's a reason I chose that, because that will leave the coefficient positive.
Okay.
There's no problem. You can have your x's on the right, your numbers on the left. It's just as valid. But I prefer to go with whatever leaves you a positive coefficient for x.
Okay. So would it be if you subtract 4x from each side? Is that what?
Correct.
Since it's positive 4. So that would just be 4x.
Okay.
And then
that and that. Okay.
And then so you could subtract 4 itself from 54, so then you get equals.
Hold on.
Wait.
Always remember you got to do the opposite of whatever it's doing.
Oh, okay, so then it'd be 58.
Yeah, it's being subtracted right now. So if you're going to get rid of it, you got to add.
Yeah.
Same thing with if something's multiplying, you got to divide. If something's dividing, you got to multiply. You always do the inverse or the opposite. So 58 plus 2, 60.
Yeah.
And x equal.
Oh. 15.
And the exterior angle measurement is.
Exterior angle measurement. So you would take 8 times 15 minus 4 equals 116?
Uh-huh.
Okay.
And it's always a good idea to look at that and approximate it. You know, are we in the ballpark? If we'd have come up with an answer like 82, we'd have known we were wrong, because we can tell that that is an obtuse angle. Okay? I'm sorry, I got distracted by a text that just came in. But that's fine. Okay, let's see. Do we have one more, or is that it?
That's it.
Good, good. Very good. Yeah, and notice at the top, geometry with algebra, which is generally what you have, is geometry with algebra. In other words, at least half of geometry is going to be algebra, because you take your knowledge of these things and you turn them into an equation. So that's what you're always searching for, is what kind of an equation can I make? All right, Kendall, I will talk to you next time.
All right, thank you.
You're welcome. Bye-bye.